Okay, Assalamualaikum and good day to all of you. So today we will continue on the last topic of chapter 5, and then the title is multiplexing. Okay, so the outline of this multiplexing, FDM, TDM, and also WDM. Okay, so for the introduction, okay, so the definition of multiplexing is the transmission of information from one or more source to one or more destination over the same medium. Okay, and then the definition, the process which two or more signals are combined for a transmission over a single communication path. A process where multiple analog message signal or the digital data stream are combined into one signal with the aim is to share an expensive resource. Okay, so this is the definition of the multiplexing. Okay, so it make the communication a very economical by transmitting 1,000 of independent signal over a single transmission line. Three predominant way to multiplex: frequency division multiplexing, time division multiplexing, and wavelength division multiplexing. So there is a three type or three predominant way to multiplex: FDM, TDM, and WDM. Okay, so multiplexing allows several analog signal to be processed by a one analog to a digital converter ADC. Okay, several phone call may be transferred using a wire. Okay, when you use the multiplexing, you just need using one wire. Okay, the multiplex signal is transmitted over a communication channel, which may be a physical transmission medium. Okay, the multiplexing divides the capacity of the low-level communication channel into several higher-level logical channel, one for each message signal or a data stream to be transferred. Okay, so the reverse process, also known as a demultiplexing. Okay, so the multiplexing can extract the original channel on the receiver side. Okay, so we have a multiplexing, and then the reverse process of a multiplexing, we call it as demultiplexing. Okay, so multiplexing techniques may be further extended into a multiple access method or channel access method. For example, time division multiple access or TDMA. Okay, multiple access method makes it possible for several transmitter connected to the same physical medium to share its capacity. Okay, so this is the concept of multiplexing, the block diagram to show the concept of multiplexing. So we have the multiple input signal, and then we have a marks, or this is for a multiplexing process, and then we have a demarks for the multiplexing process. Okay, so at the multiple input signal, so we have for example, we have a signal 1, signal 2, till the n number of signal. Okay, so for example, signal n. Okay, so we have the multiple input signal. So we want to transfer it using a one communication channel. So we need to use the multiplexing in order to transmit all the signal, and then you need to use the demarks for a reverse process. You want to convert back the signal to the original input signal. Okay, so the concept of multiplexing. So you have marks to multiplex the data, and then you have the single transmission line, and then you have a demarks to convert okay, to convert back the signal, so you can produce the original input signal. So you can produce the original signal 1, signal 2 till the signal n. Okay, so this is the concept of multiplexing. Okay, so you have the multiple input signal, marks, and then this is the communication channel. Okay, so this is a single transmission line. Then you have it to demultiplex, and then it will produce the original input signal. Okay, so the first type is a frequency division multiplexing, or FDM. Okay, so for this FDM, predominantly used in analog communication, widely used in FM stereo broadcast. Compatibility with a mono receiver requires only a slight increase in bandwidth, and then great advantage in increasing system capacity. Okay, so this diagram shows the transmitting end of a FDM system. Okay, so at you have the signal 1, you have a multiple signal 1, signal 2, signal 3 till a signal M. So you have the modulator, okay, as in order to produce the signal FC1, for example, FC2, FC3 till FCM. Okay, so you have the mixer. Okay, and then all the carrier are combined into a single composite signal that modulates at the transmitter. Okay, so at this transmitter, you have the mixer in order to combine all the input signal with the different frequency. Okay, so this is at the transmitting end of FDM system. Okay, so it will transfer using the single communication channel, and it will convert back using the multiplexing concept. Okay, so it will produce, it will transmit the original signal. Okay, so you have a signal 1, signal 2, signal 3 till a signal M. Okay, so the process is each a signal assigned a different carrier frequency, and then modulate the carrier frequency are combined for a transmission over a single line by marks, and at the receiver, demarks will separate the channel by their frequency and route them to the proper end user. Okay, so the second type is a time division multiplexing, or TDM. So for this, TDM offers a greater system improvement, capable of combining various protocol and different type of a signal onto a single high-speed transmission link, and then more efficient than FDM. Okay, so the process, the transmission must be digital in nature. To transmit telephone conversation, a voice is analog signal, and the analog signal is converted to the digital and transmitted and reconverted into analog at the receiver telephone. Okay, so the drawbacks is a greater complexity and a greater transmission bandwidth is required. Okay, so next is wavelength division multiplexing. Okay, so for this WDM, cost-effective way to increase the capacity of a fiber optic communication. Okay, so this one for fiber optic communication. Make use of the optical fiber available bandwidth by multiplexing many wavelength along a single mode optical fiber channel. Each wavelength of a light can transmit encoded information at the optimum data rate. Okay, so for this type, if you have the signal, for example, signal 1 with lambda 1, lambda 2 till lambda 3, so you need to use marks in order to multiplex the signal. And then you need to use the optical fiber as optical fiber as your um, communication channel, and it will convert back using a DMUX. Okay, and then it will produce the signal lambda 1, lambda 2, and lambda 3. Okay, so this is a signal 1, then signal 2, and signal 3. Okay, so this is the example of the WDM. Okay, so that's all for today. So actually we already finished all the chapter 1 till chapter 5. Okay, so for the OBE, we'll cover on your chapter 4 and chapter 5. Okay, so please fill in the attendance. Okay, so thank you. Assalamualaikum.